Hey guys, in this video we are going to talk about canceling. So canceling, if you've already done reducing, is super easy, possibly even easier. If you haven't done reducing, you should totally let your instructor know right now, because you're going to want to definitely do reducing first before this. But if you have done reducing, you know that reducing is all about that sameness and equivalence principle that we have. We want to create something that is the same. It's equivalent. It's not different. It just looks a little bit different, right? That's kind of one of our big, huge principles in math. We use it all the time, especially in fractions, quite a bit. And canceling is just kind of the same thing, right? It's still about sameness. It's still about equivalence. It's still about making something that looks different but is the same. But now it's going to get even easier, right? So let's take a look at a question that you may or may not have seen before. But here's this type of question, and we've got some multiplication here. And usually what we do is two steps. First, we multiply. 3 times 7, 21. 8 times 9, 72. Cool. Then we have to reduce. Now we have 21 over 72. And we're going to want to reduce that. And we can look at it and say, okay, well, 3 goes into the top. 3 also can go into 72. So we'll divide both the top and the bottom by 3. And that's kind of the standard way that reducing works, right? We do the same thing to the top and the bottom. Never different things. Always the same. And we get 21 divided by 3 is 7. 72 divided by 3 is 24. Cool. Now let's take a look at this. If we look back at our original question, we notice that even before multiplying, we already know that 3 and 9 share a common factor. 3 and 9 could both be divided by 3. Now isn't that interesting? Because 3 is what we divided by up here. Hint, hint, nudge, nudge. Right, okay, so what are we going to do with this information? We're going to try to just divide by 3 first, like early on in the beginning. So we have our 3 times 7 at the top. We're going to divide by 3. 8 times 9 is on the bottom, and we're going to divide by 3. And what do we get? We get 3 divided by 3 is 1, and then the 7 stays the same. 8 stays the same here, and then 9 divided by 3 is 3. And if we multiply this out, now we get 1 times 7 is 7, 8 times 3 is 24, which is the same answer that the reducing got us. Okay, so reducing gets us 7 over 24, canceling gets us 7 over 24. It's the same process, right? It's exactly the same thing. It's the same goal. It's the same reasoning. It's still to try to make your life easier in fractions. But when you're reducing, you've got this like big, huge fraction up here that you then have to kind of find, these common factors for. But if you don't have to get to this really big fraction and you can just cancel out when you have these smaller numbers, then that's really awesome. So if you can kind of do this step first, it saves you a little bit of time and multiplication power later on at division. Obviously, you do need to know that 21 divided by 3 is 7, and you should be able to figure out that 72 divided by 3 is 24. So all of these things are still necessary to know, but canceling can be a little bit easier some of the time. Let's take a look at one more example because I want to show you something equally, if not more exciting. So let's take a look at this one, right? 5 over 6 times 3 over 10. If we multiply it out regular, we get 5 times 3 is 15. 6 times 10 is 60. And then we're going to want to reduce 15 over 60. And we could look and say, okay, well, maybe we could divide by both of them by 3. We could divide both of them by 5. That's better. But it turns out then that if you can divide by both 3 and 5, you can also divide by 15. So we're going to divide by 15. That's our biggest one. And when we divide the top and the bottom by 15, we get 15 divided by 15 is 1. 60 divided by 15 is 4. So 1 over 4 is the correct answer, and that's what we're looking for. That's what we're trying to get. What are we going to do over here? Actually, what we notice is that 5 and 10 share a common factor. Okay, 5. We can divide both of those numbers by 5. But also 6 and 3 share a common factor of 3. So we can divide both of those by 3. This is super cool. I'm going to show it to you in 2 steps. If we divide the 3's out, we're going to get, 5 stays the same. 3 divided by 3 is 1. 6 divided by 3 is 2. And then the 10 is going to stay the same. And then we'll do the dividing by 5 step. 5 divided by 5 is 1. This second one stays the same. 2 stays the same. And then 10 divided by 5 gives us another 2. So our final answer comes out to, lo and behold, 1/4, right? This is what we were looking for all along. It's what the reducing got us. But in this case, we just got to divide by slightly smaller numbers, and that's kind of nice, right? So when you're looking at these things, you're always going to want to check it before you multiply. It's really, really good to check and see, hey, oh, there's a 5 and a 10. Let me just go ahead and cancel really quick before I multiply so that I don't have to reduce later on, right? That's the whole entire concept. See you in class.